In this video, we're going to talk about integration by substitution and how we use it to solve calculus problems. So one of the great things about integrals is that there are often many ways to solve the same problem. There's often more than one way to solve the same problem. And let's consider this function right here. So we're given the function f of x is equal to x cos x squared, and then we're told to find the definite integral of f of x dx on the interval from 0 to root pi on 2. So in previous examples, we've done a method where we would put the argument of the cos function here in this placeholder, and we would call it just box, and then the derivative of that d box by dx would be equal to 2x. Then we would go in and put that into our integral here. So we would put in the x, or we would put in our placeholder here, and then we would multiply it by this d box by dx, because the idea is that we want to get it into a form that is suitable for integrating, and in that case it would be something that looks like this. So we would have cos something, okay, the integral of that would be the then multiplied by the derivative of the placeholder with respect to x, and then that would give us the sign, okay, the sign of that placeholder plus c. Okay, so that's the whole idea, is to put this expression into this form so that we can integrate it and get it into so we can get into a form where we can integrate it. So then we go on from there, we'd substitute our placeholder back in, so we'd substitute 2x back into this box here, so we would have this function here, and we would want to have it multiplied by dx, right? And as we can see here, we already have an x, so the only thing we have to do to make this, turn this into a 2x, is just multiply it by 2, right? Because we want to multiply by dx here, and dx is 2x. Since we already have an x, all we have to do is just multiply by 2, and now we have 2x. And then we would multiply by 1 over 2 to keep the function the same. We would bring this 1 over 2 outside of the function here, and then we would have this expression here. So now this whole expression is still the same thing as this expression here, but also it is in a good form to integrate, right? It is now in this form here, right? So we have cos x squared, right, times dx, which is 2x, or sorry, d box by dx. So when we do that, we would get 1 over 2 times sine x, and then on our intervals here, from 0 to root pi on 2, we put that in, and then as a result we would get our answer, which is 1 over 2. Now, there's another way to do this. It's a little bit shorter, but there is something else that you do need to remember. Okay, so let's we're going to use a method of placeholders again, but we're going to use it slightly differently. So let's scroll down here and create a little bit more space. Okay, so we'll use a different placeholder. We'll call it something else. We'll call it t instead of box. So we'll say let t, okay, let t equal this little box here, okay, that whatever's in that argument, which is x squared, and then dt, so the derivative of t with respect to x is going to be 2x, like so. And then from this point on, we can now put the expression in terms of t instead of x, right? So we have this right here. We have, I'll show what I mean here. We'll put in our integral, and I'll say cos t, it should be cos t times x dx. Okay, so what we've done is we've just taken this instead of making it a x squared, we'll put in t instead. But as you can see here, we have an x dx, okay, and we want to have this in terms of t. So how do we manipulate this? Well, what is x dx? Well, if you look up here, remember how we have dt by dx is equal to 2x? What we can do is we can actually switch this around. So we can rearrange this expression here to look like this. So we'll bring the dx here, and then we'll divide both sides by 2, and it'll look like this. So we'll have d, which I'll write it with this color instead. We'll have dt over 2 is equal to x times dx. Okay, so you see we have this here. Okay, so what we did was we divided both sides by 2, and that brought the 2 down here. And we multiply both sides by dx, and that brings the dx up here. So now we have x dx. We can substitute this dt divided by 2 for the x dx here. So that's what we're going to do. So we'll bring this over. Okay, so we have cos t times dt over 2. So that's the next step. So from this point on, what we're going to do is we're going to take the, another way we can write this is this way. Okay, so we have cos t times 1 over 2 dt, okay, 1 over 2. Let's fix this here. 1 over 2 dt. And then we can take this 1 over 2 outside of the integrand, and then it'll look like this. So we have our 1 over 2 times cos t dt. So as you can see here, this is a little bit quicker than this method here, right? This method requires a few more steps. This method, not so much, right? Because it's easier to get to this form here. Now, one thing to take caution in is, since we've used this method, okay, since we were changing this, since we're integrating with respect to t, the intervals now have to be changed, okay, because we're not going from, you know, x equals 0 to x equals pi on 2. We're going from t equals something to t equals something up here. So that means we have to put these two intervals in terms of t. So in here, okay, the intervals are from 0 to root pi on 2. Now, if x is equal to, use a different color here, okay, if x is equal to root pi on 2, so that is this top interval here, okay, the top number. What would it be if it was t? What would t equal? Well, we know here that t is equal to x squared. So that means t is going to be equal to root pi on 2 squared, which is just going to be pi on 2. Okay, so that's what this will be up here, pi on 2. Now, if x is equal to 0, okay, remember t is equal to x squared, so it'll be 0 squared, which is just 0. So this right here would be 0. Okay, so that's the only difference between integration by substitution and the previous method that we used, is that we're going to be changing the intervals. So now that we have it in the right form, we can go ahead and actually integrate it. So when we go ahead and do that, we get this. We get the integral from 0 to pi on 2 on 2, or actually write it this way. The integral from 0 to pi on root 2 of x, well, of x cos x squared dx is equal to 1 over 2 times the integral from 0 to pi on 2 of cos t dt, which will give us this expression right here. So it'll give us 1 over 2 sine t from the interval of 0 to pi on 2. And then when you put those numbers into your calculator, you'll get 1 over 2, okay? Which will be the same answer as this one here. So that is integration by substitution, and in the next video we're going to do another example to solidify it a little bit.